Hello.
What is up? I am Anthony Campolo, and you are Josh Goldberg.
That's me. Anthony, how's it going?
It's going good. Welcome back. This is JavaScript Jam, and yeah, this is going to be my first time hosting this as a host. I was a guest a while ago, but yeah, I'm working at Edgio now, so I'm really excited that we're getting back into the recorded podcast. We've been doing JavaScript Jam, the Twitter Spaces, for a while every week, Wednesdays. And it's a ton of fun, but I really enjoy these because we get to dig a little more into the code. We get to have a little bit more of an in-depth conversation. And yeah, Josh and I have already spoken on one of my podcasts, FS Jam, and that episode will be coming out in a little bit. But yeah, we're going to be talking about TypeScript. But why don't you introduce yourself and tell us a little bit about your background and how you became a TypeScript aficionado?
Sure. First of all, hi. Thanks for having me again. Nice to see and chat with you. I have slides, but they're just an outline. I don't want to give you a whole college style lecture. But I'm Josh. I focus on static analysis tooling around open source stuff in JavaScript and TypeScript land, meaning I'm a full-time open source maintainer. I don't work for a company, although Edgio is a pretty cool place to be. Nicely done. I just work on kind of the shared tools that people in the development ecosystem, you and I, play around and need and use. I also worked on a book that published about middle of last year called Learning TypeScript through O'Reilly. It is my favorite book for learning TypeScript, and I'm very proud of and happy with it. But day to day, I generally work on TypeScript ESLint, which is the tooling that lets you run ESLint on TypeScript code. So I imagine many of the people watching, listening here, I hope, are at least are using that.
So what inspired you to become an expert in TypeScript over anything else?
A few things. One, I really like JavaScript. I like the web. When I was in college, which is how I mostly came into tech, I was learning C++, and C++ is cool. It gives you a lot of control, but it takes forever to do anything. JavaScript, HTML, CSS, you slap some crap onto a page and voila, you have a working app. It's wonderful. So I think the ecosystem is really cool. All these things we're constantly iterating on and building up. But all of my projects that I made before TypeScript were buggy messes, and I really appreciated the stability that TypeScript let me add to my code. It let me document what I was trying to do, what things were supposed to be, and then it would yell at me when I inevitably constantly mess that up. I also really like the documentation piece of TypeScript, that if I look at a project someone else has created, I know what their intent was. I know they were asking me to pass an object with these fields there or a string in that other place, and I don't have to kind of guess through what the code is supposed to be. So those are why I like TypeScript.
So you like that it adds structure to the code, basically.
Yeah, which is funny because it is a system called structural typing.
Huh. Interesting.
The things that I find amusing might not be. Sure, yeah.
Yeah, I don't know anything about what different typing systems are, what even that means.
Oh, duck typing, structural. So JavaScript is what's called duck typing, coming from the phrase, if it looks like a duck and quacks like a duck, it's probably a duck, which predates, I think, programming languages. Maybe. Not sure, actually. TypeScript is structural typing, which means you have to declare what structure things are. Like if you have say a variable that's supposed to be an object with a field message and a field times, you have to assign an object with those fields on it. You can't just assign like a Boolean array or something. But anything that happens to satisfy a structure is allowed. So if, say you have a function that's supposed to take in an object that has a length property of type string. You could pass in an array. You could pass in a string. You could pass in an object with a property length. Doesn't really matter, which is different from a lot of more traditional, even object-oriented type languages like C++, C#, where if something adheres to an interface, you have to explicitly say it is that interface. So I really like that convenience of TypeScript, where it forces you to add structure only where you want it or only where you need it.
Cool. Yeah, well, we get into your slides.
Cool, yeah. And feel free to... I'm comfortable with being yelled at, so, interrupt me is a good way to go. But cool. So right. I want to quickly jump into what is TypeScript and why we want it, and then I'll start doing a bunch of code snippets if that sounds good to you. But TypeScript, a lot of people say these phrases, and I've heard very, very few relatively explanations of what they actually mean. TypeScript is a superset of JavaScript, or TypeScript is JavaScript with types. On its own, that is technically accurate and precise, but it's not much information. JavaScript describes your code's values. You say there's a variable or a function or an object. But TypeScript goes one step further. TypeScript allows you to declare your value's intent. You can say that there is a variable, and then you can also say what is supposed to be inside that variable. String, number, array, whatever. And this is really good and useful because when you just have JavaScript code, you oftentimes don't have a description of the intent. You don't know what's supposed to be in a variable. Is it supposed to be used in a particular way? Is a function supposed to return something? Now, people have added systems to JavaScript like JSDoc, which is just a bunch of comments, but those systems are often imprecise. They can fall out of dates. Nothing really enforces that you keep your JSDoc in sync, unless you have a system like TypeScript that really validates and checks. So just to illustrate why this is useful, I want to play a game. Anthony, do you like games? Are you a big game person?
Depends on the game.
Okay, I don't think you're going to find this game very fun because it's very hard to win. So, sorry. I was hoping for an unequivocal yes, but oh well. Is this safe? One of my favorite JS games. Is this run function safe? In pure JavaScript land, we have no way of knowing whether this function is set up correctly based on however we may or may not be calling it in the surrounding code base. It looks safe. It's a function that takes in a property object. It's got action and prefix. We call action. Prefix is probably like a string. But we don't know. Maybe action isn't always provided or prefix isn't. Maybe the action is asynchronous or the prefix is a function to be called to get the string. There are all these different things that we don't know just looking at the code. So what I'd like to do is build up TypeScript so that we can explain how this function is supposed to work in a safe way and be warned if we're calling it in an incorrect way. Does that sound good?
Yeah, because it's really the action there that's the black box.
Mm-hmm. Yeah. What if it's supposed to take in parameters? What if we wanted this run function to return a value from the action? Nothing is stopping us from messing this up. So before we do that, one last slide. I promise this is the last info one. TypeScript isn't just a programming language. It's a few things built on top of that. So the programming language is JavaScript plus some new type-specific syntax that we'll go into. And on top of that programming language, TypeScript also provides a type checker, which is a program that reads in files and lets you know if there's a mess up. If you say a variable is supposed to contain a string, and then you assign it a number, the type checker is a program that will read your code, understands you messed up, and yell at you. On top of the type checker, there's then the compiler, which is a program that runs the type checker and also outputs equivalent JavaScript. Different programming languages and industry areas use the word compiler differently. So this is just the terminology in the TypeScript land. And then the one thing that I find the most incredible and beautiful about TypeScript is the top of the puzzle, the language service. There is a set of programming stuffs you can use for TypeScript that lets it run in your IDE or editor. IDE is Integrated Development Environment. For example, VS Code. So as you're typing in VS Code, you get real-time little red squigglies, or if you want to click a light bulb next to a variable and select rename variable, it'll assist you in renaming. So because TypeScript allows you to declare the intent of your code, you get these really powerful dev tools like find all references, rename, move to new file, and so on. So that makes me happy. And one example
I think this is really like the core of what people love about JavaScript, because with you can have the type safety and you can have a compiler that yells at you. But if you have a visual thing that yells at you on the screen, specifically in the code where it is, without having to run a command to tell you, then it's like you have a constant compiler running that's always checking your code at every given point in time. Yeah,
definitely. I can't imagine going back to working without this type of stuff. I used to do this. I used to use Notepad++ or the Ubuntu text edit for C++. And it's just such a miserable experience with all these tools missing. Yeah. Cool. So let's look at TypeScript. VS Code is what I personally use, and it comes with really good TypeScript support, but you don't have to use it. For this talk, I'm actually going to be on the first-party online IDE, typescriptlang.org/play. That is a URL. And if I can figure out my Mac shortcuts, first try. Amazing. This is TypeScriptLang.org in Chrome. And on the left, we have a text editor. Fun fact, this is a text editor called Monaco, which is the text editor VS Code uses. A lot of the same shortcuts are in here.
Yeah, so I was going to say, you're still using VS Code. You're just using a browser version.
Pretty much, yeah.
And it would be silly
they actually
not
have
to. It's
VS
like
Code in the browser,
TypeScript
too.
Because TypeScript and VS Code, they're like, it wouldn't really make sense to use anything else because that is the thing that was like built for TypeScript, and TypeScript was built for it, you know?
They're very linked together. I know some people use like WebStorm or other things, but I never got into them. And now that Adam's
that would only be just because some people are so obsessed with it and there's a lot of specific workflows that are specific to that editor. So that makes sense if you're willing to give up some slightly nicer TypeScript integration for the conventions you already know in that editor, but it's got to be a subpar experience.
I imagine so. I also do want to note, I've accidentally given people the impression that TypeScript is only doable in these advanced editors. You can write it without integrations. You can also get those nice integrations in Vim, Emacs, basically any other text editor, but I like VS Code. But cool. So this is the text editor on TypeScriptLang.org/play. On the left, we have TypeScript input, and on the right, we have a few things we can look at. We can look at the JavaScript output.js. And this is about the same code, depending on which compiler options you're using, which we, thank heavens, will not be getting into. You might have like a use strict there or something. But it's pretty much the same. So when we say TypeScript is a superset of JavaScript, that's what we mean. That a lot of JavaScript code, almost all JavaScript code, is just valid TypeScript code, technically speaking. Like the syntax is the same. So you don't have to learn a new syntax the way you would with like back in the day CoffeeScript or now like ClojureScript or anything. Sound good so far?
Indeed.
Cool. So first thing I want to go into is type annotations. And this is the end result snippet, and I'll then play around with it in the editor. So the first new type syntax that TypeScript gives us is the ability to declare what stuff is supposed to be. Now, a lot of the times you don't need this. Like if you have a variable that has an initial value, TypeScript knows that that initial value is just the type of the variable. Like if you have a value variable, which I realize is a poor name given my last two sentences, TypeScript knows that that thing is type string. But if you want to, say, create a variable and then later on give it a different value, you can add this new type annotation syntax, colon, space, and then the name of a type to declare later on I will only use these types in that variable. So if you say declare that a variable maybe is type string and assign it jam, that's fine. But then if you later on say assign it a number, TypeScript knows, aha, you buffoon, you simpleton. That's my internal monologue, not TypeScript's. It's not supposed to be a number. It is supposed to be a string.
So
let me just play around with this.
How does it know 1337 is a number if you didn't tell it was a number?
It knows because 1337 is a number. Great question. So let's say let value
but
string.
Would it still be a number if it was in quotes?
It would be a string. That's a good point. And there is a syntax feature in TypeScript where you can specify it's not just a string, it's like a string specifically matching a pattern. But by default, it allows any string, which actually is I think a sometimes common source of issues in olden days JavaScript, where people would pass in a string and then sometimes, okay, use it as a number. But if we know it's a string that looks like a number, it should be fine. TypeScript doesn't allow that because that is a bug farm right there. And also, fun fact, if in your editor you hover over a value or a variable, you'll see the type of it. TypeScript knows that this const value is not just any string. It's specifically that string, the what's called primitive. Sorry, the literal. I always mix them up. But this maybe is a string that is the primitive string, not the literal JavaScript or 1337. And this little red squiggly, we can also see the full list of errors in your code under the Errors tab. Type number is not assignable to type string. That's on specifically now line 7. So I don't know if you were trying to outsmart TypeScript there, but TypeScript wins. Sound good so far?
Yep.
Cool. So TypeScript is smart. It knows that stuff is only supposed to be assigned of a particular value if you say that it is that value. And in fact, actually, one more thing. If you say let later also, let's say, equals hi, whatever, TypeScript will assume that a variable, if given an initial value, is only ever going to be the same type as that value. So here, the later also variable is inferred to be type string. And in most TypeScript code, especially TypeScript code that I write, I try not to use type annotations unless I actually need them on variables. Most of the time, there's an initial value or it's a const or something. But cool. Moving on. Parameters. Sometimes you do need to add type annotations. Now, TypeScript can run in a mode where you don't declare any types. It's called implicit any's, which is saying anything can be any type unless I say otherwise. But normally it's a good idea to tell TypeScript what types of function parameter is allowed to be.
How do you do that where it's just assumes everything is any?
Ooh, great question. In the online editor, sorry, I think I misspoke there. It allows anything to implicitly be any unless otherwise declared. So in the editor, we have, here we go. We have a bunch of strict options that I'm just going to turn off.
Okay, and so
normally
let's stop and talk about this right now, because this is the thing that confused me forever with TypeScript,
sure.
Which is like there's TypeScript and then there's like 1,000 config options that create infinite numbers of TypeScripts. So what?
Sure. Thank you for stopping me. This is a good thing to go over. So yes, there are many config options. The TypeScript team does not want there to be many config options, but that is the necessity of working in JavaScript. It's just, yeah. They have an actual label on the issue tracker, new config option or something like that, because of how often it gets requested. Just a bajillion different ways people write JS. But one of the biggest reasons why we have all these config options is because different people want different levels of strictness for TypeScript. Sometimes if you have an existing, 3,000 line project or 3,000 file project, that can be kind of difficult to make the most strict, accurate, specific types as possible. So it's nice to be able to say to TypeScript, okay, just find out what types are when I tell you, and otherwise just don't yell at me. So like TypeScript will always yell at you if you declare the type of something and then mess that up. But let's say you declare a function parameter. Logarithm prefix. I forgot what I actually called this in the slides. And then you say like prefix hi or message. Let's say hello message. Now, right now, TypeScript under the more strict options would say parameter message implicitly has an any type, meaning you haven't told me what type this parameter is, so I can't tell you whether you're using it right. Now, sometimes that's a good message. Sometimes people don't want to be allowed to do that. But other times it's you should add a type here because the any type is dangerous. It lets you do anything you want. So where am I config? There it is. So if we turn off no implicit any, then TypeScript will no longer yell at us for that. And if you look at the options in the playground around, where is it? Here we go, around type checking. There are all sorts of different things, like strict function types. Don't even get me started on whether one function is the same type as another. Strict property initialization, whether class members need to be definitely assigned in the constructor. Just, I think, like a dozen of these different strict ones. So a lot of the configurability comes from that. And there is a catch-all strict option, which enables all of them if you didn't have them originally. Except for apparently no implicit any. Is that kind of what you were looking for?
Yeah, the reason why I asked is because I feel like when you're starting someone off on it, it can be a good, like you want to have a default that's going to allow them to use TypeScript as much as possible without having to like get stopped by like a really obscure kind of type error that they can't figure out and ends up being a blocker for them.
Absolutely, yeah. The way that I personally try to go for is I will get people to do best practices, like enable the really important ones. But if there's something that would be so difficult to resolve that it requires non-beginner, even non-intermediate knowledge, then yeah, we should push that to the
Because
side.
sometimes you write
And thankfully you
code
can.
that is perfectly acceptable and it does exactly what you want, but because of how TypeScript is set up, you need to write code with logic in it that is not related to the logic that you want your code to perform, because there's like TypeScript stuff embedded within it that's like its own language.
Yeah, which is the worst experience in the world with TypeScript when you're adding JavaScript to deal with TypeScript. Do not want. I will say a few good best practices. Shout out to Scott behind the scenes for suggesting. In general, yes, enable strict and no implicit any, but you can always use an any if you really need, which is an explicit type annotation saying, hey, this is anything. Let me do whatever I want with it. I'd say if you are writing a lot of JavaScript to get around TypeScript, then it's probably the case maybe that your type system is not reflecting reality, that what you've declared in your types isn't actually accurate. So your code is maybe getting confused on that. I'll also say that most of the time complex types are a symptom of complex logic or conceptual ideas in your code. So if you're writing like 300 lines of conditional TypeScript types, which is a monstrosity we will not be getting into right now, then it might be that your code actually is understandably difficult. Like it is difficult to understand your code. So I'd say the simpler your code, the better in general, and specifically the better for TypeScript.
Yeah, this is where you get caught up though, because it's like if you have a giant JavaScript code base that's complex, like then you can't like rewrite that to be less complex so it will be easy with TypeScript. Like you're kind of stuck with it.
Yeah. But if it was complex for TypeScript, it was probably complex for the people reading and writing it too, no?
Not if it's a whole bunch of magic that was underneath the surface because it's like a framework or something.
Yeah, TypeScript doesn't like magic, I will say. There is a limited permissiveness in the language for that. And honestly, TypeScript is not always the best solution. If you have so much magic in your code base that you get so much value out of it that it is more valuable than removing magic and adding in TypeScript, well, then just don't use TypeScript. That is a valid situation. I will say TypeScript brings a lot of value, so you have to have some pretty darn good magic to overcome it, but it's not impossible, not unheard of.
Yeah, with Redwood, it was like over a year-long process to get TypeScript to work because it was such a magical framework. And for us saying, just use TypeScript wasn't an option because they're like, we're not going to because we don't do that because we are TypeScript.
That's rough. I'm sorry you had to go through that.
Oh, I didn't go through
you and everyone.
I was the developer advocate. Developer advocate does not write types.
Got it. You know, it's actually an interesting thing. I've seen a lot of companies, open source projects, etc., start to have TypeScript first documentation where they will write in TypeScript and then like maybe have a tab for JavaScript to just tell people, no, it's the same. So I'm curious. I'm guessing you write JavaScript first.
It depends. I would say it is going to be dependent on what is kind of the purpose of what I'm writing, because I don't write like super duper complicated examples for like my DevRel stuff. Usually I try to always provide the simplest example first. And I find that if I'm trying to do that and I'm trying to explain something like specific to whatever the SDK is, then it might not necessarily make sense to add other stuff that would make it the code like type safe if the point is not to write bug-free production safe code. It's to like render a concept in a logical way so that they can understand it. So I don't think it necessarily needs to be in TypeScript, but I understand the argument for having both because there'll be times when you want to learn it in like TypeScript. But I would start TypeScript first if I knew it was going to be like a really serious production type example app, or if it's like using a framework that doesn't really make sense to not use in TypeScript. Like there's the Create T3 app now, which is what got me into TypeScript. And with that, you literally can't turn TypeScript off. Like the framework doesn't make any sense without it. So there's a lot of good reasons to start TypeScript first, but I am still on kind of like a case-by-case basis.
That makes sense. I really like that. I think that most people should be on a case-by-case basis. You should intelligently put the thought into such a critical decision if you have the time. Fortunately, I almost always end up in TypeScript, but, that's me. Cool. Any other thoughts or comments, questions on the config stuff before we dive more into the function parameters and such?
I guess like when you're starting a project like in your editor, like how do you like scaffold out like a TypeScript project? Because that was the thing that was challenging for me the first time, is that I didn't know how to start a project, and I could find other TS configs as like examples from other things, but I didn't know like if I just was going to like start, like what were the things that you would need to configure, and what are the things you kind of leave off and it would be inferred? What's the tooling, like what libraries you need to install, all that kind of stuff.
Great question. Let's do that. Code jamming. So I have a new VS Code winner here. The most important thing to do for any new project is I'm just going to use npm, even though I personally often use pnpm now, is to install TypeScript. So that'll get you, come on, npm. Well, there we go.
Yeah, it's because we're streaming
package.
and you're screen sharing, so there's always additional lag on your npm installs.
I love it. Yeah, the first thing I would do is npm my TypeScript save dev. There we go. The second thing is create a tsconfig.json file. Actually, before I create it manually, the TypeScript npx or TypeScript has an init. Sorry, TSC or TypeScript compiler, their command line has a TSC --init, which creates a tsconfig with some pretty good defaults in it. I'm going to delete anything that's a comment just to get them out of our hair.
What's the difference between TSC and TS-node?
Ooh, good question. TSC stands for TypeScript compiler. It is the compiler that comes with TypeScript. It does not run your code. It just type checks it and turns it into JavaScript if you want. TS-node is a toolkit that combines TSC, give or take, and Node. So it both compiles your code from TypeScript syntax to JavaScript syntax, and it then also has Node run it. So it's like a really nice shortcut to be able to take a TS file and run it directly in Node-ish. Because you can't do that normally. Node does not understand type annotations, type-specific syntax.
Unlike Dino.
Which is actually a downside of TypeScript, that it increases complexity. Yeah, Dino was just like, well, what if we made Node way better? We added more secure defaults, we added better APIs, we removed a lot of the cruft, and first-class TypeScript support. Beautiful.
Which Ryan Dahl said he kind of regretted.
Cool. Well, everyone has regrets. I think for me, Dino used to, in addition to transpile, turn your TypeScript to JavaScript, it also used to type check code by default. And I don't believe it does that by default anymore. Because while transpiling code, removing out the TypeScript specific syntax is normally pretty fast, type checking can be pretty slow because it's much more complex of a thing to do. So
cool. Thank you for that. Yeah.
Progress. But yeah. A few things. So these are just the settings that are enabled by default in a new TS config, and it's what I'd recommend. ES module interop. There are weird differences in the JavaScript community between old style of modules and new style, so this helps massage those a little bit. Like if you have a package that doesn't have a default export, but you want to use it like one, this makes that a little easier. Force consistent casing and file names does what it says. Module changes what output format your modules use. So let's say that you wanted to npm I React. And fun fact, you also need to npm I at types-react save dev because the React package does not provide a description of what it looks like to TypeScript. So there's a community package called at types/react. Let's say you wanted to import React from React and save that as your index.ts, and then just console log, I don't know, like I have React. If we start the tsc-w, so the TypeScript compiler in watch mode, we get index.js. And this lovely little syntax bit here uses exports. I'm going to turn on word wrap. Uses exports because that's like the common JS way. And this syntax is kind of weird. It's spooky. So I'm going to, oh God, that's even worse. So if you want your code to be written in fancy new modern JavaScript modules, but outputs old style common JS, you can, or you can do ESNext as your module. And instead it outputs what we see in the playground of just basically the same thing as the source. So that I think is one of the biggest complaints, gripes, confusions people have starting up TypeScript is what is the difference between module, say common JS or ESNext. I'm curious, is that something you've had to wrestle with before?
ESM versus common JS. Oh yeah.
Yeah.
Yeah, because I am really into Vite, and so I find myself sometimes using Vite for something that is maybe a couple years old and was not created for Vite. So then you're in this position where, you maybe have one file that needs to be MJS or CJS or something, and it doesn't quite make sense. So like once you get into having to change the file types, then stuff really gets confusing because you may have a file type and you may have some code in it, but the two things might not necessarily make sense together if the tooling was built in a time before all that,
Yeah. What a nightmare. TypeScript does have support for MTS and CTS files. Fun fact. So if you have a .mts file, it'll call it MJS in the output. However, you don't have to use TSC, TypeScript compiler, to compile your code. A lot of projects, especially web ones, will use something else, like Webpack or SWC or Vite or whatever, to take your TS files and turn them into JS files. So oftentimes, honestly, in most of the bigger projects that I do that are web-based, I don't even configure TypeScript's output. I use a setting called no emit true, which says just type check my code, don't transpile it into JS files. It's like if we delete index.mjs and JS and then keep running, we don't get the JS file. So then I can have some other tool like ESBuild or whatever.
Okay, that's really interesting for that, because that's the thing where when you're learning this stuff, everything that TypeScript does happens usually in a single step. Like it makes sure there's no errors, and then it will like compile it, and then because you're usually just like running commands with like a dev server kind of thing. So separating the actual type checking from the compilation is something I've never really thought about doing that you even could do.
Ooh. Oh yeah, I highly recommend if you have anything more complex than a command line app, or even if you have a command line app, but like type checking takes a while because it's very large. So anything more complex or big than a small command line app, I highly recommend separating type checking from compilation. For example, a lot of apps use like ESBuild, SWC, whatever, to use a Rust-based toolchain that converts your TS to JS files. Those are super fast, way faster than TypeScript. You can do that really quickly to get it to run in like a local demo or test or whatever. And then separately from that, have type checking visible in your editor, just from the IDE integration, and also in your CI step as a separate step so that it can do its thing in the background.
So is this something that you would configure this from scratch, or is there a certain framework that does this for you, or like how would you get that set up and without having to like go through the whole thing if it takes a while?
I'll say I have a repo that I've been building on GitHub in the open called Template TypeScript Node Package that has this set up already.
Literally exactly what I would want.
This one actually does unify type checking and compilation. It does not use noemit, but you could pretty straightforward switch. I actually don't remember off the top of my head how to set up SWC, but it really is as straightforward as adding no emit true to your TS config, adding whatever commands in your package you use for builds. Let's say it's SWC, like adding an SWC command. And then in CI, you have different commands for each of your individual parts of your process. Like you might have a build command that runs npm build or pnpm build, and then you might have a copy of that runs TSC, TypeScript compiler,
Yeah, that's
and call that type check.
See, here's where you get into like, okay, so sounds like a nice setup, but you just told me I need to install a dependency that I know nothing about, write a GitHub action in YAML. And it's like you just like you've already just added a pretty hefty chunk of stuff. So that's why I feel like having a template or an init command are like a way to do that. And yeah, I remember the first time I tried SWC was like beginning of 2021, and the docs were like so sparse it was like incomprehensible. Like I didn't even know how to get it to run like at all. I didn't even know what was happening.
Sure. I mean, that's part of why TypeScript does it for you by default. The basic setup is fine. If you want to do things separately, you can, and there are a bajillion different ways of doing it, which is why it's kind of hard to find a unified template. But something like you mentioned T3 app, which is fantastic. I actually recently started contributing to it a little bit for DevTools. Next.js comes with options to separate out type checking and linting from your local builds, like one line options. So there are things that do it for you. But yes, unfortunately in JavaScript, the state is, because everything is in flux, if you want to get your particular Eden, your perfect state, you got to get your hands a little dirty.
Interesting.
Such is life. I came into this assuming we'd be talking about syntax features and type checking, but I'm now thinking what's most useful to you, and I'm guessing the viewers as well, is configuration.
No, I mean, yes and no.
That is rather complex today.
Everyone comes at this from a different place, and everyone has their own issues when they hit it. So for me, I had already seen enough JavaScript code out in the wild to like at least have a sense for it when I first started using it, but I hit all these issues with the kind of build tooling and things, because as you're saying, there's a lot of ways to do things, and there's not good templates. So they just say, you could do it a bunch of different ways, pick one and then do it. And it's like, okay, but then I need to figure out how to do it,
Sure. I mean, if you have all the time in the world, it's fun. But yeah, I can certainly empathize with not having all the time in the world to learn every tool out there.
This is also why I keep telling people about T3 app, because I'm like, if you haven't been able to figure out how to set up a TypeScript project that actually does make your life easier and not harder, you should use a framework that actually gives you the correct defaults from the start.
Yeah. I mean, JavaScript is catching up with the rest of the world, or the rest of the development tool chains. Like no one just creates a .css a .cs C# file and then runs .NET manually. They use Visual Studio or frameworks within that and project templates. And so now we're figuring out what those templates should look like. But I personally think it's going to be quite a few years more until we have a good set of standard templates that last more than a few years. I think we're still iterating super quickly on everything.
Yeah. All right, we can get back into language features and stuff. That's probably good.
Sure. I like complaining about JavaScript. That makes me happy. But cool. We went over a little bit on parameters. So you can add a type annotation on a parameter in a function to tell TypeScript that anything passed in here must be that particular parameter. So just real quick, if you say log, I called this in the slides, log prefixed. If you pass in hi, that's fine. If you pass in, let's say true or something, Boolean is not assignable to parameter of type string. Yay. But now we get to the fun stuff. In the example run function, I said I want to be able to pass in a destructured object. Let's say for a simpler one, I want to do message in times for let I equals 0, I less than times, I plus equals 1. Let's say I want to console log the message. And this is something that, unfortunately, TypeScript isn't great at, showing you a lot of errors at once and not giving a lot of context. Some of these messages aren't super clear, no one, I think, really understands what the term binding element means unless they work with language syntax a lot.
Yeah.
But basically what we're saying here is
super hard for me is when you get the error messages, then you can't even read the error message because it has all this terminology in it that then you have to go figure out okay, well, this error say I need this. So what is this? And then you find examples that tell you how to fix the error in a generic sense. And then you got to reverse engineer that to your own code and figure out what the actual issue is, and then map their thing to this thing. And yeah.
It gets hard. I will say there is a really nice VS Code extension that I just had to look up called TS Error Translator. Let me see if I can find my VS Code window. Here we go. TS
these links in
Error
the chat.
Translator. It's by a... Absolutely. Once I find it. It's from Matt Pocock, who is a very well-known, influential content creator
TypeScript.
person in the TypeScript community. Yeah, and Dan Abramov invented React. I don't know if it's this. It's been a while since I used this. Let me get you that link.
There's a link earlier in the episode also. I'm
Few
forgetting
helpful
what it
tips for
was right now.
TypeScript. Me too. TypeScriptLine.org/play. There we go. So there is a tool, and this has an associated website linked somewhere in its docs, where if you have like an obscure complaints function, hi. Let me actually just copy this stuff over. Let's see. Okay, so not everything has a translation, but the TS Error Translator, here I'll just go to the website, is this cute little app Matt Pocock made where it will explain a lot of the more convoluted and common error messages from
This is
TypeScript for you.
great. It's a shame we need it, but
I'm told it's quite
great.
useful. Yeah. I'll also say the TypeScript team has an open call for please help improve our error messages. It's very difficult for a programming languages person working on a programming language to figure out what is the best error message, both because they're so steeped in it and because they have so many competing priorities to work on. So if you have an error message that you think is not great, like the binding element one, and you have an idea for how it could look better, you can always file an issue on TypeScript saying, hey, this could be more clear. Here's what we could do.
I haven't tried yet asking ChatGPT to explain my TypeScript errors, which probably work better than people think.
Ooh. I've had some pretty bad results from ChatGPT on TypeScript errors, actually. Great results on a lot of other things, though, like conference talks. Cool stuff. But just to show how to actually resolve this error, for this one, it's saying these elements implicitly have any type because I haven't declared a type for them. So I say I want to declare like a log options type. One of the ways to do this is to declare an interface, which is saying whenever I say log options, what I mean is any object that has the following properties. I'm going to say message, string, times, number. So now if we hover over them in the parameter, we see message is string, times is number. And I realize I like using fancy shorthands, so I'm going to split it out. The commented out code is just syntactic sugar for this. They do the exact same thing. So message is a string and times is a number. That way, if you pass in the wrong thing, say you pass in an object with nothing on it, TypeScript will let you know, hey, are you in a type empty object is not assignable to log options. You're missing message and times. Sound good so far?
Yeah.
Cool. A couple small features here. If you want to use a default parameter, let's say, you can. Say you want to default times to 1 by default. So you just pass in, say message, hi. Now, here we haven't told TypeScript that times is optional, but if you put a little question mark before the colon, then TypeScript knows that it's allowed to not exist. And TypeScript even knows if you enable strict null checks, there we go, that if you try to use a value that's potentially undefined, because let's say it's optional here, so you're allowed to not provide it, TypeScript will let you, hey, you're comparing against something that might be undefined. That's not allowed. Yay, TypeScript. I will also note that you can actually use the question mark in other parameter annotations. Like you can just say a parameter is optional, like log maybe might take in a message string. So you can say like log message or lat. You can also provide a default value, in which case TypeScript will tell you you don't need both the question mark and the initializer. So you can just remove that. Parameter cannot have question mark and initializer. And then you also don't even need the type annotation because TypeScript knows if it's got a default value, it defaults to that particular type. So these are all different syntax ways that TypeScript tries to help you out and lets you declare what your code is actually supposed to do.
Okay. So
Cool.
We're coming up on, we got about 10 minutes left till we hit the hour. So just want to make sure we're going to like get through all of your slides and stuff.
Yeah, this is basically all I wanted. One last thing is if you want to provide a function parameter, just real quick, this is the syntax to do so. You can say that this property is type takes in, let's say, a value is a string and then returns void for nothing. So I have to provide action, which does whatever. Let's say my action just like console logs value. So that's just the syntax. So TypeScript allows you to declare how a function looks. So that's about it. That's all I wanted to cover today.
Cool. Yeah, no, I thought that was
we have interfaces,
great,
function types,
yeah,
and that's about
crash
it.
Course. And I always like people who like kind of start off in like the playground like that, because like TypeScript is something that there's so many ways to use it and to think about it and to get an entry point into it. But just starting with like the basics, like how do I put the type on the thing is the most important thing you got to learn first. So it's really good. I've seen you do this almost exact presentation a couple times actually for some of my friends whose streams you've been on, and I really like your style. You're very like step by step kind of type guy, so I think that's really useful. And so are there
Thanks.
Let's make sure we fully plug your book. Why don't you let people know where to go to kind of see that and buy it and give you money?
Sure, thanks. I will note I put unique types in the slide. That's the term for something that could be one of multiple types, like the string or undefined we looked at. Sorry, the number or undefined. The resources we went over here are TypeScriptBlend.org and that/play. And then my book, yes, learningtypescript.com. I would by the way, first of all, again, thank you for letting me plug my book. I know not everyone learns with books. I personally really like books, and this is how I would teach someone TypeScript. So if you want to get it, it's on Amazon, Google Books, Barnes & Noble, and so on. LearningTypeScript.com has all the links. Also a bunch of practice projects for each of the chapters, which go through more and more intense TypeScript stuff. And then also I have a GitHub sponsors. You can sponsor me on github.com/sponsor/Joshua Goldberg. You can also sponsor the work that I do on TypeScript ESLint, which is the tooling that lets ESLint, and also prettier, fun fact, run on TypeScript code, TypeScript-ESLint.io, and opencollective.com/TypeScript ESLint.
Yeah, and I would say, where can they find you?
Thanks.
But you've had both your Twitter handle and your website conveniently placed at the bottom of every single one of these slides. So hopefully people already have seen it.
Yes. I will eventually update this to include Mastodon. I'm on Fastodon. But yeah, while Twitter is still alive and somewhat kicking.
Yeah, I heard people started defederating from the server that I was in for reasons. So I ended up just deleting it because I had like 2 toots on it. And I'm like, all right, well, I guess Mastodon was not meant to be for me.
Oh, well, we had a nice thing and now we don't. Such is life.
Cool. And then, I think that's probably it. Any final parting words for our viewers and listeners?
Thanks for tolerating me. Feel free to reach out if you have any questions. If you have a complex type, it might be because of complex code. So get mad at your code before you get mad at TypeScript. And, support open source maintainers. Give us money so we can make life better for you.
Can I just be mad at the complexity of the universe itself?
Oh, my constant state of being for me right there. You've described my mentality in a nutshell. Yeah.
All right, this is going to close it out for us. Thank you, everyone, for watching, and thank you, Josh, for being here, and tune in next time for more JavaScript Jam.